Person stands on a cliff that is 55 meters high, throws a stone up in the air. The stone hits the water that's below the cliff a few seconds later. The approximate height of the stone is given by the following formula. When will the stone hit the water? So the when part does that make sense that we're solving for time? The hit the water also tells us something important. What is the height of the stone when it hits the water? You start 55 meters up, you throw it, it hits the water. What is the height of the stone when it hits the water? At 0. You're starting 55 meters up, and the stone goes down 55 meters to hit the water. The height of the stone would be at 0. With that in mind, we can set up our equation. We plug in 0 for h. It's a quadratic equation. You can either factor and use the zero product property, or complete the square. Some things I would do. Okay? I'm going to move everything over to this side because I like either factoring or using square rooting to have whatever my squared item is positive.
Shouldn't it be plus 30t?
No, because I moved this over to the left. Oh wait, I moved the 30 over, makes it minus 30.
Plus 55.
And then the 55, when it moves over, it'll be minus 55. Because you're moving everything to the left-hand side. So, right, what you do to one side of the equation, if I add 5t squared, I add 5t squared to this side. If I subtract 30t, I subtract 30t on this side. If I subtract 55 on this side, I subtract 55 on this side. And that would move everything to the left side. Can you see that everything divides by 5? So if I divided every single thing by 5, I can do this because what you do on one side of the equation, you do on the other side of the equation. That will give me t squared minus 6t minus 11 equals 0. Zero product property, you'd have to be able to factor this. How quickly can you tell that this can't be factored? Right? If it can't be factored, then we have to solve by square rooting. Solving by square rooting would say leave a space, move the 11 over to the other side, leave a space. The hint is the minus 6t. To get a t squared, it would have to be t and t. The minus 6, your outside and inside, when you square something, give you a minus 6. It would have to be a minus 3. Again, we notice sort of this shortcut that 3 is half of 6. Now, if it was a minus 3, and you multiplied it out, would I get a plus or a minus 9 here? A plus 9. So I get a plus 9 on this side. Give me 20. Square root both sides. Add 3 to both sides. Write this in lowest terms. And we get our answer. However, Mental math, do you see that the square root of 20 is somewhere between 4 and 5? Because it's between the square root of 16 and the square root of 25. If you did 3 minus 4 point something, you would get a negative number. And in this word problem, that would mean that you threw the stone and hit the water minus 1 seconds before you threw it. So in word problems, not only do we have to solve it, but then we have to analyze the answers within the context of the problem to see if they make sense. And this is the only one that makes sense. And we would also lose a half a mark in this question if we left it like this, because we didn't include units. Any word problem that has units requires that you have units in your answer. So you need to have the seconds there as well.
Question. It also says to round to nearest tenth.
Oh, and it says to round it to the nearest tenth. Thank you. So now, this would have been nice because if you would have went to your calculator, you would have seen the one answer to be negative. So if it asks for an exact answer, this is your exact answer. The question asked to the nearest tenth, so now we have to use our calculator and solve this. Something interesting, if you take out, for those of you that have a graphing calculator, if you take out your calculator and go to y equals, I'll clear what I have, and I had, scroll up here, take the original equation, 55 plus 30t minus 5t squared. 5 plus 30t. Now you don't have a t, but you have beside your alpha button an x button. If I hit this, I can graph it. Probably your window might be set on the standard window, looks like this. Line goes up. If I change my window just to show, I'm going to go up to 100 because I knew I was starting at 55. Person threw it up pretty high. And then it comes back down. Does it make sense that this x-intercept is our solution? Because this is us starting on the cliff here, throws it way high in the air, comes back down, hits the water right here. And on your graphing calculator, above the trace button, it says calculate. If you go second, calculate, it lets you solve all sorts of things. What we're finding right now is number 2, an x-intercept or a 0. So the way the calculator works is it says, gives you a little cursor, and it says push enter when you are left of your 0. Do you see that anywhere I'm right now? I'm currently to the left of this point. So I can push enter, it draws a little line for me. Then it says go to the right. I can move my cursor until I pass my x-intercept and I'm on the right. It draws another arrow. Is my x-intercept between those two arrows? It is, so when I push enter on guess, it finds the 7.5 for me that way as well, which is pretty neat. So we're going to be learning some of these things on our graphing calculators as we go as well. Okay, questions for practice on this last one? 6 and 7.